Okay, so today we'll try to solve this problem, minimum window substring, and the reason is it's one of the few problems left in my new code things. So let's get started. Let's see. Given two strings S and T, return the shortest substring of S such that every character in T, including duplicates, is present in substring S. Okay. Mm, right now it is always unique. So that's okay. That makes the problem pretty straightforward since we would have only one answer. I'm basically trying to understand the first example. So x, y, z, x, y, z, x, y, z, yeah. Okay. X, x, y, z, x, y, z, and x, y. X should be an empty string, empty string. Okay. A few way. Recommended primary space is of m plus n, that is of n time, and okay space. So, okay, let's see how to handle situation. Application allocation the shader setting. I think I will be going that bad. Oh, let's see what it is. Okay, so for this one, what I would initially do is, okay, just give me a moment. Yeah, if you so the content. Yeah. Okay, let's get started. So my initial brute force approach will be go through S and get all the substrings possible from this piece. Then we would check each of the substrings for, like, we would have a hash map for this T, and then we would, for each of the substring we would use a hash map, and we can keep using it most likely. Yeah, we can. And then I would just compare that the frequencies being matched with each of the substring. For example, this is going to be the substring. This specific substring will have the frequencies as one, and it will also have additional one, but we additional one for A, but we don't care about it. So this is the only one substring that has all these three letters. So, but that would essentially make of n squared for grabbing all the substrings, and then O of k for O of k plus O of k, yeah, hash map for each of them. And then I would be going through all the substrings. That should be an O of n linear loop. Okay, I think at this point I'm just yapping. So what I'm basically mean is we would, for the brute force approach, we can follow S and grab all substrings. I think having a text box there would be more useful. Okay. So we can grab S and grab all the substrings. And once I grab all the substrings, what I can do is I will be using a hash map, use a hash map for T, and then we would go through the we would go through the substrings, which we go through the substrings, and Then for the substring, we will basically just give me go back. Yeah. Okay. Okay. Then for the substrings, uh, we will be using a hash map. Use another hash map for each substring. That would basically allow me to compare this frequency, uh, and this frequency, and subsequently grab the final answer. So what I'm expecting is here I would have what of n squared, like two for loops. So of n squared, and then here I would have another for O of n squared, we would go another O of n. So that's like O of n cubed. So nowhere near our required recommended time. We can another another way for these window problems is basically having a sliding window, and we can I think we can use a two-pointer approach for this. Let's see. So let's try to keep it clean. Oh no, no, not like that. Yeah. So we have O U Z O D Y X U Z and B. So yeah, O U Z O D Y X A Z B. This is the substring that we are dealing with. So how can you do it? Let's try to figure it out. We would need a hash map for T, so that's for sure. And how can we kind of use two pointer for this approach? We have a left pointer, we have a left pointer, we have a right pointer. Suppose I will be moving only one, that's true, so right pointer. So until I grab all the values, I should be going right? Because yeah. So initially what I'm thinking is I would keep going right until I have my required setup, that is x. Okay, we would have a hash map like this. X is 1, y is 1. Oh, yes, so it's just here's this. So we would have a hash map like this. X is 1, y is 1, and z is 1. And until I achieve this specific state, I would keep going right. So that would basically bring my right pointer to this point here. At this point, I am sure that I have everything in my window, and now I can start shrinking. So for that, what I would do is basically think about how can I shrink it. Okay, if I at that point I would have, what would be my state? O is 2, U is 1, then I would have Z's, which is 2, I would have 1D, I would have x and y as 1, x is 1, y is also 1, and a and z. A is 1, I'm going with z. So this would be the state. If I move my left pointer, I would be reducing one of the O's. But that doesn't really matter. I don't care about it because our state is satisfied, right? So we can keep going, right? Let's say we would go here now. So z gets reduced by 1, and we don't care about it either because our state is perfect. We keep going right, our O gets reduced to 0, we don't care. We keep going right, D gets done, remove our Y. At this point, my my thing, that is L, suppose, okay, so left pointer is here, I remove it, Y becomes 0, this state is nullified. So at this point, I would have to buckle up and say that no, I can be removing that. So I would be having a pointer for the last valid one, right? I would have a pointer at this place, y, and yeah, okay, I need this whole window. So I would also need a length of the smallest piece. So I would have to, so from this, what I can snip out is we would need something like a start pointer and a length, minimum length, let's say. Okay. And then, so our state is nullified. We keep start here and keep going on. At that time, our, let's say we go to the right and this thing just ends. We can't help it. So I think it's a viable approach. We were kind of code it up along the way carefully. Let's see. So for this, let's say first. Okay, how are we doing on the time? Okay, 13, not bad. First, if the second substring is is larger, if t dot size is greater than s dot size, nothing can be done. Just return this because cannot accommodate a larger string and a smaller string. So if t is bigger, then no. And secondly, if that doesn't happen, what I would initially do is have an unordered map of character and integers, and let's call it map E for character C in T. I would have the count for each. So map T, oopsies, no, sorry, map T character plus plus. Okay, now we have the frequency map for T. Let's say we will start traversing S, and the left is equal to 0. We want to start both from the same place, right is equal to 0. Then, oh no, 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 no. We would start a forward with, it keeps going to the right, right? So for R is equal to 0, R is less than S dot size, R plus plus, for the specific uh, iteration. What do we want? Initially, I would have to keep track of the map, right? Yeah. But we also need the size for this. How can we do it? Insert it in the map, right? Initially. Okay. What I'm trying to, what I'm confused about is how to track the state. The second hash map, so we would be using two maps, that is for sure. So let's say we have another map S, right? Yeah. So map S and map T. So for map S, left is 0, right is 0. So we have our map S, and then we put in that character, which is this is to see if we have the string. How do we track that, right? So we have this state, and we have another variable. So int minimum length is equal to int max, because we would have to know that. And we would also have to have a start variable. That's all fine. You could debug it from here, right? But what about we would need another variable to kind of track the farmed versus unfarmed situation. So let's say we have int. Let me do it. S map T. We have this piece. This one's the. Okay, what can we do next? Think about it. Maybe the notes, okay. I need to check, right? I need to check as I'm progressing through this. I have O, I have U, I have Z, I have O, E. At each point in time, I need to be verifying that whether this thing is being satisfied. So what I can do is I have to check the sizes of the things like hash maps. So if our map is dot size is equal to map not equal to is greater than or equal to map t dot size, at point what do we get? So there could be a potential match, right? If that's the case, map s dot size is greater than the map t dot size. It's promising. We would check the hash maps. Check hash maps. So how can we do that piece? We would basically go through each of the maps. So for auto, C comma found in what? In map S, right? Yes. In map S, we would check if if map S map S C is equal to oh, right? What we're trying to do here, we are going to map S, right? Map S greater than equal to map E dot size. Okay. Hmm. Hmm. Check if the map S, and are we gonna iterate through the whole map or just if we have more elements, we don't mind, right? Yeah, we don't. So let's iterate through the larger set, which would be our this, like S, and then we would go through its value counts. So map S C, that is map X, element of map S, that's count, like count of that piece is equal to oh yeah, got it. It should be map T. So map T's C key is C and is equal to count is of map S's value. Okay. If that's We can do anything T and then do S here. If that's the case, we are iterating through map T, map T, and then we will check if map S C. So if map S's element or key, that is value is equal to count, if that's the case, for each of the element in map T, it's not equal to count, we would keep expanding, right? We would keep expanding. That's expanding. So let's just see how this that's gonna expand at its own pace. Check the first map S, right? Yeah. Then we do map S dot size is greater than or equal to map T dot size. Hmm. Why don't we do one thing? If map S dot size is less than map T dot size, we can just continue, and then what the continue basically do? Uh, while right is inbound, we do right plus plus. Okay, but if they are equal or greater, then the ball is in our court and we can do this. Check check the hash maps for auto C in map T. We'll go through the whole map T like this. This is our T. And for each, we would compare the values like with map S, match the count, and if they are not the same, we would keep expanding. There's no way of knowing what's happening. So we would keep expanding. If thank you. Want to grab, let's see, you have this piece. Okay, you have this piece. Right. Yep. Okay, it's kind of a tough cookie. Um, I don't know whether should we keep expanding or not. If they match, the hash maps match, what do you think about it? If the hash maps match, we can go into our survival mode and say we would have a Boolean flip, which is false. Let's say for like farm, we have like a farm situation here. If now when I'm iterating through some values of that size where we can fit in, and our this piece is satisfied. Uh, so if not, then we would do farm is equal to false. Otherwise, our farm is true. Nah, makes sense. False. Initially, we don't have it. If it's equal, equal, you can just have it as true, right? I think we can have that. If it's not, then how do we code against it? With the code, right? So the only reason I'm trying to keep false here is I have to code against it, right? So if false, you can always do the not, but that's doesn't make sense. So or we can just have the size here. If not that size, it's less than that. And continue. The children hash maps if not S, the key is this. You can get the value. If it's not, then determine one is equal to false. You have to here. Then what we can do is our found is true and okay, found is true. That is, we have our hash map satisfied and it's of that minimum size. If that's the case, then we can keep shrinking. So what I would do is while it's form this image, you'll shrink it. How do we shrink it? We would to left plus plus or what? No, not that. It would be character remove is equal to SS left pointer remove that character which is would have to have the start somewhere. Um, I don't think that's gonna work because I can just remove the characters from this map here, but we are not. We won't be marking. So, for example, we can just do that S minus minus. But if we do that, when are we marking the start? We mark the start if this map is satisfied, right? We can try. Let's do that. Well, what we can do is I think I have a way out for this problem. Why not just when we're doing this maneuver, like when we're looking to it, let's just say we grab the carrot here, see if this is right, then once I have that, what we want to do is like put it into the window for that. What we will do is map this C plus stress, right? So if this character has now reached the capacity, it's like required frequency, then we would, yeah. So what I was planning is instead of having this, we would track it instead of having a Boolean tag. Let's say we have this, we would track the formation of each required key of letter. So as I'm going through it, I would target the specific character included in the window, and then we'll check if it has reached the required prefix already or not. So let's say we would do if our map t dot count of c, right? We would grab the count of c, and that is it basically exists. It because what I'm trying to do is map tc is equal to map sc. I can't do that unless I know that in map t c exists. So if this character has now, that's our target basically. So not bad, it's pretty decent. So let's say we would have this. I would do form plus plus. Now I have this form to compare with. So if form is equal to uh yeah, the the formation of each required character. Checking the formation of each required character, right? Uh, so we have formed is equal to 0, but if formed, we are in a situation where formed is equal to our map t dot size, right? Then you can start shrinking. and we would shrink as long as it's valid. So wide. So oh no no no. Just think about it. Let's do this. So remove the left character. That's really done. So that's gonna be character remove is equal to map t's. Or sorry, not s left. Then we would do math is remove minus. Then what I want to see if removing removing disrupts my state. So but basically understand if remove sorry if form this is oh we have to modify the form as well. All right. Oh no 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 no. If okay if removing the structure state if removing causes the required frequency for character to drop. So what I will basically check if that that character's count, which is that t dot size or not map t's remove is less than this is remove. If that's the case, oh, we can make sure that we have that element. No, not here. If map t, so there is a window. If oh no, no, left is not the window. If our map t, it should be not s. is the target. So we need this much. If we have this much, one minus minus, then question is where do I do that start thing? Oh, I can start here though. If form is equal to empty dot size, anyone? No, that is not enough. That is not enough. We have to make sure that we pick the frequencies. The way hmm, formed is already checking that frequencies are matched. So if that is done, we can just update our smallest. What we will do if our right is plus one is less than minimum length, we will update the minimum length. One is equal to right minus left plus one, and also start is equal to left, right? Yeah. Mm, so shrinking. So that is our final string operation. So left plus plus. So what we would basically return is return is start and length. How do we system return? So substring, you can use a substring as dot substr. This, but oh yeah, if we are technically handling case where we don't have anything like that string. So if like if the two strings have completely, so if minimum length with max is the numbers for max return an empty string. See what's happening. Debugger here. So start is getting stuck, right? Hey, he can't be doing that. Remove isn't S is left, remove S is left. Man, not mathematics, it's really S. And it's just not S, remove it. Oh, still no. Okay. Uh, I am the only logic that I would be missing to do not.c and check whether this already exists. I would have debugged it, but if we could debug it, that Notebook doesn't have it, maybe people has it. I'm not wrong. Yeah, maybe they have. Mhm, mhm. So the problem was my intuition was I am removing character, but I'm not checking whether my required need list, which is map T, has that requirement or not. So only if this element exists in map T and the frequency doesn't match, we would be doing form minus minus. That's for our logic. Because we're doing form plus plus only if this scenario is happening, right? So, yeah, that is it.